All right, hello again, out of two people. So we're going to continue with our series on quadratics now. In the last video, we talked about how to convert from vertex form to standard form, just kind of by multiplying, combining like terms. Today, we're going to go backwards, and we're going to go from standard form back to vertex form in something called completing the square. Before we do that, let's kind of review real quickly what those two forms look like. So vertex form we know is a times x minus h squared plus k, where your vertex is at that hk value. And then of course standard form looks like y equals ax squared plus bx plus c. You're going to hear me talk about the b term a little bit today. So and when I say that, that's just the coefficient of the x term, and of course a coefficient of the x squared term. Okay, so again, if we're given standard form, it'd be a nice thing to know how to find the vertex, right? And in full disclosure, there is another way you can find the vertex also from standard form, but this is kind of the surefire way to do this. Takes a little bit of algebra, but once you see the pattern, it's really quite easy. And frankly, it's easier than doing the other method and can be faster once you get good at this method. So to do this, it's kind of giving an explanation. I'm going to ask you guys to pause the video a couple times, especially if this is your first time going through this, to really try to see the pattern on your own before I kind of say it out loud. Okay, so this is what we did yesterday, or in the previous video, I should say. So remember, if we take x plus 4 quantity squared, if we remember that pattern, we don't even have to do FOIL or the box method or whatever. We just know that pattern is going to be this, right? How do we know that? Because we can take 4 times 2 to get 8, and then that is going to be the 16 is just 4 squared. And that happens every single time, right? Just like on this one, if you got x minus 7 squared, negative 7 times 2 is negative 14. So it'll be this, and then negative 7 squared is 49. Okay, so now what I'm going to ask you guys to do is take that same pattern, but now can we go backwards? So in other words, if I see x squared plus 10x plus 25, how can I go backwards and write that as x something squared? So if you can pause the video for 1 second and think about that, what would go in those blanks to make that happen? So hopefully you have those answers. So again, we look at this value right here, and if we take that value divided by 2, that's 5, so we know it's going to be plus 5. And of course, it works because 5 squared is also 25, right? Same deal. If we take this guy right here, this b value divided by 2, negative 16 divided by 2 is negative 8. And again, negative 8 squared would be 64, so that works also. Okay, so hopefully already you can see that pattern and kind of see what's happening. Now we're going to take it, but now we're going to take it 1 step further. So now I want to add a term. So I got the x squared and I got the 6x. So in other words, I got my ax squared and bx, right? So I want to make this a true statement by doing the same thing. So, but now I've got to say, okay, what goes in both blanks? Okay, so I think the easiest way to do this is kind of color code them. So take a look at your b value and say, what would go here in this green space? Same pattern we did right above. And then, if we know that, what number would end up being right here? Same thing in the next example. What would go, if that's our b value, what number would go right here using the pattern we did right above? And then going that number, what number would go right here? So again, think about that. If you need to pause the video, you can. But hopefully we see that if we take, on the first example, if we take plus 6 divided by 2, that means that's going to be plus 3. And then if we square that number, that plus 3 squared, it's going to be 9. And that would make that work. Same thing in the next example. If we have negative 12 divided by 2, that's going to be negative 6 here. And then if we square that, remember it's always going to be positive. Negative 6 times negative 6 is 36. Okay? So really what we're doing, we're taking the b value, dividing it by 2, and then squaring it to rewrite that inside part. Okay, so doing that process, guys, and that's all there is to the process. Doing that is called completing the square, and it's a very, very useful technique, not only in algebra, but as you go on to other upper level math courses, you're going to see it kind of pop up every now and then. So how can we use this process to take something like the next example right here and say, okay, that's my function in standard form. How can I use this same process to find the vertex and write that whole thing in vertex form? So here's what we do. So we're going to take the x terms and just kind of separate them out. So I'm going to do it like this. So x squared plus 8x. I'm going to leave a space, close the parentheses, and then put the 13 out here. And then what I want this to be equal to this, so x and then something squared plus, whatever's left over. Okay, so use what we just did. What's going to go, and again, I'll color code it again. So I want something here first, so using what we did up just on that top line up there. And then I want to add a number here, and then we'll talk about what happens next. So what's going to go in that green space? So again, to do that green space, we take the b value, divide it by 2. So 8 divided by 2 is 4. And then to go in the blue space, we take that number we just wrote, that 4, square it, which would be plus 16. Okay? Now, here's what we have to do. The reason I left a space after the 13 also, listen, I just randomly added a number in that parentheses. I changed the function. So if I added 16 inside the parentheses, I have to subtract it outside the parentheses. So I've got to undo whatever I do inside. Okay? So, but now I can kind of clean everything up. I've already got the inside done. 13 minus 16, it says minus 3. So look here. That's basically, I'm done. So on the right-hand side there, that is my new function. So I got y equals x plus 4 squared minus 3, and that is our old friendly vertex form. And right off the bat, I know that my vertex is -4, -3. That's the whole process, folks. Separate them out, and then just kind of do that process of dividing the b by 2, adding it in the parentheses, squaring it, and then cleaning it up. So I'll go and do one more example, and I'll let you guys pause the video and do a couple of them on your own. So here's the next one. So we got x squared minus 10x plus 29. Same thing. Separate, leave some spaces. So again, so the first thing we do, take the b value divided by 2. So -10 divided by 2 is -5. -5 squared is plus 25. And whatever we add on the inside, we have to subtract on the outside. So now we just clean that up. 29 minus 25 is plus 4. And I'm done. That's the whole process. So my function is y equals x minus 5 squared plus 4, and my vertex is 5, 4. So I've got two more where my leading coefficient, my a value is 1. So go ahead and pause the video and see if you can do those on your own. I will give you a warning. On the second example, the one x squared plus 3x minus 5, you're going to get a fraction, but fractions are people too, so it's okay. So go ahead and pause the video, do those, and then I'll kind of zip through those answers in just a moment. All right, so x squared plus 20x plus 93. Separate. So 20x, so 20 divided by 2 is 10. So this gets a plus 10. 10 squared is 100. Subtract 100, undo what we did inside, clean it up, and there's your new function. And your vertex, of course, would be -10, -7. On the next example, again, you're going to get a fraction sometimes. It's okay, but it works the exact same way. So again, 3 divided by 2 is just 3 over 2. If you want to write it as 1.5, you can do that too, but I'm going to use your fraction. 3 over 2 squared, so 3 squared over 2 squared is 9 over 4. And again, whatever is inside of here, we subtract on the outside. And of course, we need a common denominator here. So this is going to end up being -20 over 4 minus 9 over 4. So it's going to end up being -29 over 4. And so that's my function. I'm done. Nothing else to do. Y equals x plus 3 over 2 minus 29 over 4. And then the last one, so we haven't done anything where you have a leading coefficient yet. So I had to get one of these in. There's a little bit of a wrinkle here you got to think about. Okay, so notice in this case I have a is 2, so 2x squared plus 24x plus 67. We're going to start it off the same way, guys. So we're still going to do 2x squared plus 24x, leave a space, plus 67. But before I keep on going from there, I want to basically factor out that a value. Okay, kind of think of it as a GCF. Notice I'm only taking the 2 out. I don't care about the x's and anything else in common, just that leading coefficient. So I'm going to write it like this. So 2 parentheses x squared plus 12x, 24 divided by 2. And then I'm going to do the exact same thing I've been doing. That 2 is going to hang out. Okay, and again, same deal. Just work on the inside. So 12 divided by 2 is 6. So this is going to be 6. 6 squared is 36. But here is the other wrinkle. Okay, when I subtract, and I'm still going to subtract something on the outside, but I'm not subtracting 36 this time. I'm subtracting 72. Why is it 72? Well, because of this leading coefficient. I added 36 inside, but really I'm adding 2 times 36. So I have to subtract 72 from both sides. Still clean that up, 67 minus 72 is minus 5. So the process works the same. If there's that leading coefficient, you just want to make sure and subtract the number times that leading coefficient. So my function is 2 plus 6 squared minus 5. And remember, that doesn't affect the vertex. That's just a vertical stretch, remember that. So the vertex here is just still -6, -5. So that is how you complete the square from standard form, going back to vertex form, and then being able to write the vertex that way. As always, you should be able to go back and forth. So vertex form back to standard form, and you can check your work that way, kind of what we did in the last video. As always, if you have any questions, you can let me know, talk to your teacher. Until next time, stay safe.